Good morning, everyone. I think someone have heard about ARM virtualization recently with Microsoft announcing using virtualization with their servers. So I've been working on ARM virtualization for the past 4 years. I've been with ARM since last year, working on mostly on Xen. I've been working on Xen since 2012, and being command name since last year with Stefano Stabilini, one of the creators of Xen on ARM, for the project. So what is virtualization? So everyone is here about virtualization, but what is it? Virtualization is the fact of creating a virtual version of something, like creating a virtual version of a computer to be able to run multiple operating systems on the same platform, or creating a virtual version of the disk of a device. When people hear about virtualization, they often think about cloud, but it's not only clouds. It's also in everywhere from IoT to enterprise. Like for instance, you could use on your phone to be able to have your phone with your OS specific for your specific for the so I was saying, so like you bring your phone at work, your work wants specific applications, specific operating system, but you still want to be able to install your Angry Birds on your phone. So you may want to have using virtualization one OS, one Android for your work on one which is not protected for you. The second one would be in industrial, like you want to be able to be easily upgrade your hardware, but if you upgrade the hardware, usually you will have to upgrade the operating system. So by using a virtualization, you will have a small layer where it will be easier to upgrade only the hardware, only the virtualization, but not the operating system. Last one is about automotive. So like on automotive, you will have a lot of things to do. You get autopilots, you get UI, you get camera, etc. So you want to be able to partition this work and keep inside the same, on the same hardware. On the last one, which is the most known, is on enterprise, like for cloud, to be able to share resource between different companies or different entities. I would say there is two main types of hypervisor. So there is the bare metal hypervisor and the hosted hypervisor. In the case of bare metal hypervisor, so from the bottom to the top, you start the hardware, you start the hypervisor, and then you create all the guests, the VM. In the case of type 2 hypervisor, you start the operating system, like you start Windows or Linux, and then you start your hypervisor. So for instance, VirtualBox would be the case where you start the hypervisor after starting the operating system. So that's why we call the Linux, the operating system the hosted operating system, and then you put on top the virtualizations. So this is type of virtualization, but also you need to run your guest. You have kind of different kinds, let's say, of virtualization. I would say the first one would be, which has been the main one at the beginning, was full virtualization, where your guest is not aware to run on the virtualization. So everything is being done like you use hardware assisted virtualizations to be able to run like the processor, multiple guests at the same time. All the input, output from the guest are emulated. Like for instance, you will use QEMU or any emulation on the driver on the hypervisor side. So that's one of the first one. But the problem of that is if you use full virtualization, it's slow because every time you do an I/O, you have to emulate them. So second kind of guest, I would say, is para-virtualization. In this case, the guest is fully aware to be able to run on the operating system. Every time you do a specific instruction, like you want to modify the page table, there is instruction on every architecture about that. Rather than doing that, you will replace the instruction by a call or an hook to the hypervisor. On all the devices like network, disk, etc., are virtualized. But the problem of that is it requires a lot of modifications in the guest because all the guests are using page table, modifying page tables everywhere, so every time. So you have to modify heavily the codes. So the new trends, I would say, is a mix of both. So you use as much as possible hardware when you can to, like for instance, to be able to handle the page tables, to be able to handle the interrupt controller. And for anything that requires a bigger impact, like the disk on the network, rather than emulating them, you would use para-virtualized drivers. So the guest is aware of the hypervisor, but you can still use as much as possible what has been used for bare metal. So you can still use a bit of virtual emulation, but it's very limited to what needs to be done. You don't emulate the disk or the network. So I would say this is the main subject of the talk, ARM virtualizations. So ARM virtualizations is, before speaking about that, I will speak quickly about the ARM architecture. So the latest architecture is ARM v8, which support both 64-bit and 32-bit guest or operating system or software. There is 4 levels of 4 privilege levels. So the higher level is EL3, which is a secure mode, and the lowest level is EL0 for user space. It's possible to have a mix between 32-bit and 64-bit on the same platform, but always the higher privilege, like for instance, if you run the hypervisor in 64-bit, you won't be able to run the secure mode in 32-bit, so it's always a higher privilege. The second thing is within the same exception level, you can't mix between 32-bit and 64-bit, so you won't be able to have a guest. An operating system having a bit in 64-bit, a bit in 32-bit. But you will be able to run your, let's say, Skype in 32-bit on your platform and GIMP in 64-bit, etc. So you can mix the applications between 64-bit and 32-bit. Regarding the ARM virtualization, it has been added on ARM v7. So ARM v7 was only 32 bits, and they decided to start adding virtualization there. It's a new execution mode, which an higher privilege as EL1, which is an operating system. So it's running between the secure mode and the operating system. So when you want to do virtualization, it's not only saying you add a new mod. You have to add few features to be able to use as much as possible the hardware. So the first thing you have to do is memory. How do you use memory in this case? Because the guest will have its own set of page tables where it translates a virtual address to the physical address. But in the case of the VM, the physical address is not the host physical address. So you add a second set of translations to translate what's the view of the guest for the physical address to the real address in the host. And also, you need to improve a bit the TLB to tag them with the guest ID, what we call VM ID, virtual machine ID, to avoid having to flush the TLB every time you context switch between guests. The second thing you want is when you do a guest there is many instructions. So you have instruction to modify the page tables, instruction to access the floating pointer, etc. You may want to be able to trap some of them. So you want to trap the page tables, but you don't want to trap the floating pointers. So we allow also to say, OK, I want to trap the page tables, and all the instructions for the page table will be trapped. So the hypervisor decides what he wants to trap and what he wants to emulate to control what the guest is doing. Now, so a guess is you have page tables, you have memory. Now you want interrupts. You want to be able to receive the interrupt for a device, etc. So because it's shared, what is done is that all the interrupts are coming to the hypervisor, and then they will be forwarded to the guest. And there is hardware now to be able to forward directly the interrupt to the guest. And the last things you want, I was speaking about para-virtualization. In the case of para-virtualization, you need a way to communicate with the hypervisor to ask, for instance, can I get access to this device, or I need to send an event to the backend of the para-virtualized driver. So there is an instruction, HVC, hypercall, which is similar to the syscall on Linux, where you call from the user space to the kernel. But in this case, you call from the kernel to the user space. So it's allowed to do paravirtualizations or being able to communicate with the hypervisor. The last thing is, so this is great. You got your processor to be able to virtualize, but you also want to be able to virtualize the root controller, the SMMU, etc. Because if you don't do that, you will have to emulate or paravirtualize, which means much more code to the gas. So all the standard architecture from ARM is also virtualization aware, so you're able to multiplex, multi-gas at the same time. What's EL2, the new hypervisor, is not a superset of EL1. It's more an orthogonal mode of the operating system where you are able to run multiple EL1 at the same time. So what you do is the hypervisor will be used as a world switch, a context switch between each hypervisor, so each guest. So if you want to run one guest, you save restore all the registers on etc. You move back and forth. It has its own translation regime, so you can use virtual address directly in the hypervisors. There is no stage 2 because the hypervisor is in control of all host physical address. No, the thing is, you will not be able to run any current operating system, EL1 operating system, in EL2 because EL2 on ARM v8.0 is quite small, which means that if you want to run there, you have to modify everything or a lot of things. So EL2 is used differently between type 1 and type 2. So in the case of type 1 hypervisor, EL2 will run directly the hypervisor on every guest will be in EL1. But in the case of hosted hypervisor, it's much more complicated. You have to have a switching codes because the hypervisor is part of the kernel. Every time you access from the guest kernel to the hypervisor, you have to go in EL2. And then moving back to the host kernel. So you have to context switch all the registers of the host every time. So what has been introduced on the recent revision on ARM v8.1 is trying to allow those kernel to be able to run in EL2. So they extended what they call virtualization extension, VHC, where you improve for type 2 hypervisor. Rather than having to context switch every time the register from the host, you are able to run the operating system in EL2 with the hypervisor, which means that if you look at, so that was a type 2 hypervisor before with ARM.v8.0. So what they are doing is now you remove EL1 for the host, and you are able to run the host kernel on the hypervisor in EL2, which means that every time you don't have to context switch anymore the registers. It's becoming much easier to do a type 2 hypervisor. New things, new trend. Usually, you want to be able to, you are on Amazon, you have a VM, but you may want to be able to run hypervisor inside because you want to compartmentalize, partitioning what's your resource. So we also, in the last revision last year, in ARM v8.3, we introduced nested virtualization. So nested virtualization is being able to run a VM inside a VM. So running an hypervisor inside an hypervisor without modifying the hypervisor. So the EL2 hypervisor needs to be aware of what's going on, but the hypervisor running in a VM doesn't know it's running on a VM, so you will be able to run KVM on Xen, Xen on Xen, Xen on KVM, etc., mixing hypervisor, whatever you want. So far, it's only 64-bit specific. A brief summary of ARM virtualization, why using ARM virtualization. So the first thing, it's a robust set of virtualization. It's not only doing processor virtualization, you also virtualize a lot of the hardware. And we are doing much more, like you virtualize the intercontroller, virtualizing the IOMMU, etc. It's also a scalable architecture, so ARM is best known for mobile, IoT, etc., and also coming to servers, which means that virtualization can be used from the very small thing, your watch, etc., up to the servers, and it's the same architecture. And the last thing is we don't stop on what we have today. We are always trying to improve on the architecture. So for instance, we had 8.0 adding 64 bits. We introduced ARM v8.1 with the VHC extensions on the ARM v8.2, so there is a bit more there also. On the ARM v8.3 with nested virtualizations. So we always are trying to add more features to help people to do virtualizations. So why speaking about virtualization? Where can I use virtualizations? So during this talk, I will only present a few open source hypervisors that could be used for virtualization. So I will try to explain how the architecture fits with ARM virtualization, what's their strengths, what's their drawbacks, on what could be used with them. So I've chosen 3 different hypervisors, very distinct. So there is KVM, a type 2 hypervisor, and hosted. There is Jailhouse for partitioning hypervisor, and there is Xen for a type 1 bare metal hypervisor. So let's start with KVM. KVM has been created about 10 years ago. It was merged in Linux 2620. So KVM is a module of the Linux kernel. It supports both 32-bit, which has been merged in 2012 in 3.9, on 64 bits, which has been merged in 3.11. All this code is available as a GPLv2, so you could use the code on your project. And it's also, as I was mentioning, a hosted hypervisor. In the case of KVM, so he has a very distinct features compared to all the 2 others, is using hardware virtualization as much as possible. And for any device, it could use either emulation with QEMU, so I will go explain a bit after the slides how it works, or paravirtualization with virtio. This is the design of how KVM works. So you got, at the bottom, you got the hardware with different CPU, different disk, different network. You got the Linux kernel. So KVM is taking a lot of advantage of Linux kernel with a file system, physical drivers, etc. On KVM in itself is only a small part of the kernel, which is a module, separate module. Now, in the case of KVM guest, a guest have multiple things. A guest have vCPUs, a guest have drivers, etc. He needs to discuss. So for these vCPUs, it will be handled by the Linux kernel, the scheduler. I will explain a bit later. For any I/O, what will be done is if you use QEMU, for emulations, it will go, so KVM guest will access the device, try to access the memory regions, being trapped in the Linux kernel, being forwarded to the QEMU, and then being forwarded back. The response is forward back to the kernel, and then forward back to the guest. That means that you have multiple context switch to do back and forth. So that's why you add paravirtualizations to be able to serialize all the requests on avoiding all this context switch. Now, 2 things about KVM. Paravirtualized driver on all the QEMU for the emulation for the guest are inside the hosted kernel. So it's in user space. That means that if you have 10 VM, you may have 10 QEMU running on the hosted kernel. Same for the backend. The second thing of using I/O emulations is your emulator needs to have access to all the memory of the guest, because you don't know where the guest is doing to do the MMIO access. So this could be potentially restricted with paravirtualizations. But in the case of virtio, virtio has living on the host side has access to all the memory. But the main advantage of KVM, I would say, is if your guest is unmodified, like you want to run Windows or any proprietary operating system, you don't have to make them aware they are running on the platform. The second thing is, so ARM, as I was saying, KVM is a type 2 hypervisor, which means that when you run on v8.0, you have to have this small, tiny switching code saving registers of the guest and then restoring the registers of the guest every time you access to the hypervisor, or every time you receive an interrupt. So ARM v8.0, it's a nice thing for KVM, but with the introduction of ARM v8.1, no, it's becoming much simpler, a bit faster, and you don't have to worry about context switching on this overhead. So now the kernel Linux on KVM can run directly on the in EL2 on saving this all context switch, on simplifying the code. So I was mentioning about CPU, resource management. In the case of KVM, a vCPU is just a task for the Linux kernel. So the Linux kernel we see doesn't know it's a vCPU from a guest. It doesn't know that. It just knows it's a task, and the scheduler will use that. So which means a great thing of that is you can all use all the features from the Linux kernel to be able to do the scheduling, like a C group to be able to associate priority between tasks, saying this vCPU will run on a specific host CPU, physical CPU. Second thing is, when using KVM, because it's in Linux, you take advantage also of all the hardware support in Linux. So when there is a features for scheduler, you can get directly from the kernel. So KVM, hosted hypervisor, quite fully features. No Jailhouse. Jailhouse is much, much smaller. It's only 10K of line, 10,000 lines. It has been created by CMS in 2030. So it's comparing to KVM. KVM has been there for 10 years. Jailhouse has been there for 4 years. But at the same time, they are taking a completely different approach from KVM. KVM wants to be quite a general purpose hypervisor. In the case of Jailhouse, it's a partitioning hypervisor. And they are great for that. It's a type 1 hypervisor, but even if it's type 1 hypervisor, they are using the kernel for booting. So what they are doing is Linux is booting. When Linux has finished to boot, initialize the device, you go back on top. On the Jailhouse will say, please start. And what will do Jailhouse is Jailhouse will move back below. Jailhouse will move will completely take over of the platform, take over of all the device, and say, this is, I'm in charge. Second thing that Jailhouse will do after that is you will say, I want to create different guests. So what they call on Jailhouse is cell. It's quite common, like jail, cell, etc. So you compartmentalize all the platform. And there is no power virtualization, there is no emulation. It's only using device, physical device. So one device can only be assigned to one cell. It's not possible to share device, to share CPU, etc. So they have no scheduler, they have no power virtualization thing, so that they still have some work to be able to communicate between guests. But there is nothing like when you, like for instance, you got real-time processor, you got normal processor. You can say, all my real-time processor are going to my real-time operating system, and only this operating system will run there. Same for the device. I want to give my network. The network will be there. So it's very different compared to KVM in this way, but because it's live, it also means that the way it's easier to certify. So usually when you use in automotive, when you use in any embedded like a plane, etc., you want to be able to have your platform. You want to trust your codes because you don't want your plane to crash because of a software fault. So there is certification for that. So usually certification means you have to look at the code. You say this code is fine. You have to comply to one thing. So fewer lines of code means easier to comply and to check if it's fine. So 10K of line compared to with Linux where you got everything, the hypervisor where it's few million lines of code. I don't remember, maybe it's 5. I don't remember the number of lines of Linux, but it's few millions lines of code, and it's going on, going on. So it's much harder to get a certification for that. Second thing I will say for Jailhouse is, in the case of KVM, you got this general purpose thing, so it will know all the hardware from the firmware table. So firmware table is describing what's existing on the platform and why is it. In the case of Jailhouse, so far, they have a platform, per platform information saying, this is where is my hardware on how I split between VM between cells. So the last one but not the least is Xen, bare metal. It's a bare metal hypervisor. So this has been created by the Cambridge University in 2003, so a bit older than KVM. When they started it, they're starting with para-virtualization because there was no hardware supporting virtualization. So all the guys were aware about that. No. When we moved to ARM, we decided to do completely different things. We say, OK, I want a clean port. I will explain on the next slide about that. The support of ARM has been added in Xen 4.4. It has been added a bit before, beginning of end of 2012, but we fully supported, saying that we support all the security. If there is a security issue, we support that. If there is a bug fix, etc. So we take care about that. It has been added in Xen 4.4, which has been released in 2014, if I remember. All the code also is available in GPLv2, and you are able to do guest using different guests. I will explain just after. The code base is a bit bigger than Jailhouse, so we move from 10K to 30K, but the number of features is much more. There is much more features than Jailhouse. So in the case of Xen architecture, the common architecture when someone wants to do something is you have the hardware, you boot Xen, and then Xen is really tiny. It's a unikernel, very small, a microkernel, sorry. It's really small. So we rely on a specific domain, which is called the controller domain, to handle the hardware. So this domain has fully access to the platform. He's able to use. He's able to configure the driver, the device, etc. So the domain controller is not only. We are not tied to Linux. We are not tied to FreeBSD. We are not tied to NetBSD. You could have your own domain controller, or you do whatever you want. It's not like you don't have to be GPLv2. You can have your proprietary software as long as it's running on Xen. Second thing is for DOM-U, for the guest, what we call DOM-U, is we use a mix of para-virtualized driver on using the hardware, so there is no emulation. So every time you run a guest, like you want to run Android on your guest, it needs to be able to use directly it needs to have PV drivers, like for block or for network, unless you want to do, you know that your network cards will be async directly to the guest. So in that case, you may be able to run unmodified guest. One of the great things of Xen is if you look at the other hypervisor, they rely a lot on the hosted controller when you look at type 2 hypervisor. But in the case of Xen, you can disaggregate it. So you can say that my disk driver is assigned to this domain, what we call a driver domain. So if you know that your disk driver is nasty, it may be buggy, you don't trust it, if you run in DOM0, and it crash, you will crash the whole platform. If it runs in the driver domain, you just crash your network. So it's still, it's better. You don't have like, oh, I'm using on the plane, my network driver has crashed. Oh, damn, I don't have any more access to anything. So that's the point of using driver domain. You isolate the platform. And at the same time, you give less privilege to DOM0, which means that potentially fewer attack to that. So you could have a driver domain for camera, driver domain for disk, block, etc. So you could have separating like that. So it's becoming like much more, you keep them as a microkernel and you have different service VM to be able like a network service. So that's, I would say, the main things of Xen. But on the drawback is if you don't use any, don't assign directly a device to the guest, you won't be able to run unmodified guest. Like you won't be able to run any OS that you can't modify because you don't have the source. One second thing which is quite uncommon is we don't have only one scheduler. You can have many schedulers. So we have the concept of having a pool of CPU. So you can say, I have 2 CPU in this pool. I want this domain to run in this pool, and you will be able, it will only be able to run on this domain. So for instance, we have here 3 pools, 4 actually. You got 2 CPU, you know that you have to run real-time operating system that using a real-time scheduler, the RX 653. And you have another set of CPUs that you know that it's your UI, you don't much care about the real-time thing. So it's fine if you use a normal scheduler and you can mix with the CPU. And the last thing you can do is also saying, I want to, this physical CPU, I want to pin it, which means that the physical CPU will never, the vCPU will never move from one physical CPU to another, will stick there, which means that you got a better latency because you won't have to context switch every time the registers between different guests. And also, you can receive much faster the interrupt because you don't have to move. If you receive an interrupt, if the guest is not there, what do? You have to ask the scheduler to reschedule, which means that it has a bit of overhead. So I won't say which one is the best hypervisor. I think they all have their best features. It's mostly a choice of what you want on your platform. So during this talk, I mostly wanted to expose what is there, what can be done, and to see how you could use in your project at home, etc. So I've put some links about KVM, Jailhouse, and Xen projects, so there's a good documentation in general. I will be happy to answer a question after that if you have any question about those with hypervisor. And feel free to have a look, feel free to see what could be suited for you. One thing I will say is ARM is always looking for new people. They are looking actually for people on virtualization on Xen. So if you're interested to work in UK, in England, on working in Cambridge, a nice place, just come to see me at the end, and I will give you contacts on what we are doing. Thank you for listening. Is there any question?
Guys, to encourage you to ask your question, I would like to announce that, after we will done with all our questions. Yeah, I have seen your hand. Thank you. I will ask Julien to select the answer of the best question, and this answer will be awarded by a prize from Global Logic. So don't hesitate to ask.
Hello? Okay, Julien. Well, I'm Andy Niso from EPAM Systems. Julien, could you please give more details about use cases for nested virtualization? Why ARM needs nested virtualization?
I would say,
Julien,
so,
you said...
I would say the nested virtualization, I haven't thought much about that, so you take a bit like that. I would say I can see two places. I can see one place in the cloud because you want to be able to use VM, a cloud place, but you may want to be able to partition this VM to other VMs. So the nested virtualization could be done there. The second one I will see is, and I quite like that, that company doing that, is you have so you use virtualization to partition it, but inside the operating system, you've seen a lot of companies starting to think about operating system is quite big and can be easily attacked. So some people are starting to think about separating the application on the operating system in a small VM where you have one VM per application. So that means that if your browser is attacked, you would only compromise this small VM and not the whole operating system, which means that if you want to run this operating system with this virtualization in it, you will have to support nested virtualization.
Okay, thank you.
I have a question regarding scheduling. Currently, you have only two real-time scheduling for hard real-time. It's rsync scheduling, and TDS currently is in development for soft real-time. What about multi-core support for rsync scheduling and maybe some plans for additional real-time scheduling?
So I think so. It's an open source project, so we are adding what people wants. So if they want a new scheduler, they can do it. So we designed the hypervisor to be able to use any scheduler. So we got few hooks, and you can do it. And for instance, there was a new scheduler posted on the main list yesterday to be able to do a new scheduler, so avoiding most of the overhead of the scheduler. So you can do, if you have any scheduler in mind, you want to implement it, just feel free to post the series, and we will be happy to review it.
I want to ask, is there a way to virtualize an x86 or some other architecture on top of ARM? I mean, a part of emulation.
I mean, you could use QEMU to use x86 on ARM. It's possible, but it's not. I won't be in the architecture. I don't think it's not the case today. I don't know what will be the future, but I don't know. I was reading some news about that recently, about people thinking about using x86 application on ARM because everything exists on x86, and it can be difficult sometimes to port your application, and could be easier to use emulation. But I don't think it will be planned. It's not planned so far, and if you want to use this, I would be kind of emulating each instruction.
Okay, thank you.
Julian, I
Yep.
guess if RM is moving to server side, on server side, I hope there will be need to have a x86 emulated on RM. Could it be?
I'm not convinced about that because a lot of hardware. It depends what you want to do. A lot of hardware is a lot of software. We are working a lot on software to make sure it's working on ARM64 or ARM32. So if you do that, you may not need to if the software is working already on ARM64, it may be better. Obviously, you will always have your weird, I'm not saying weird, but your old VM with running COBOL or something like that that doesn't work here, that work only on specific sets, so you will have to use emulation. But I think it's better to think that I'm not speaking for ARM as much my point of view. It's better to think that using directly the ARM instruction would be better than trying to emulate anything. It would be the same like using directly x86 instruction on x86 would be much faster than emulating. I don't know, let's see what the future wants.
I have a question. Is there the way to use advanced SIMD extension like Neon or cryptography extension in virtualized environment on ARM? Or just native application?
No, you can use. So what we do in all the hypervisors is that we context switch the registers, the floating pointer, cryptography, etc. So we got code for floating pointer, but if the crypto is specific to your platform, you will need a bit of code in the hypervisor to be able to do the context switch. But it's possible to share those devices.
Thank you.
Yeah.
Could you please compare trust zone monitor and hypervisor from the point of view of hardware isolation between guests? I mean, both of them do the same thing, basically.
I don't think both are doing the same thing because trust zone is very specific to anything secure. It's living, as I was, can I go back? Where was it? So if you look at here, trust zone is living in this secure world, so it's using secure memory, which is really trusted. But in the case of the hypervisor is about compartmental splitting the hardware between guests and ensuring that each guest cannot access. But in the case of the trust zone, it's more like you got access to you put your DRM decoding inside the trust zone. What else? Any access to something that needs to be like payments, etc. So it's two distinct things. I'm not much aware about trust zone because I'm not working much with that. But what I could say is that for me it's a very different set. Because in the case of the trust zone, you will have access secure memory. The secure memory cannot be accessed by non-secure memory. So what I was saying is like you got two worlds. The non-secure world where running hypervisor, user space and kernel space, and you got the secure world where it's running everything that needs to be trusted, like the payment. You don't want your guests to be able to tamper the payments, etc. So I think they need to work both together. So I've seen people asking for how can I use trust zone with VM? Because you may run multiple Androids. Multiple Android needs to access the video, so you may need to do decoding. They may need to do payments, etc. So you need to be able to share that. So I think what is going to happen is a much more collaboration between trust zone and the hypervisor to say, okay, the hypervisor will handling the guest being able to do some filtering and then forward to the trusted firmware. So I think trusted firmware will need to be able to know a bit of virtualization and at least know that there is multiple clients using the firmware on partition.
Okay, thank you.
I have a question. What's about stability? Can we use any of this solution in production? I mean, vehicles, automotive.
I would say any of the solution can be used in production. I know people working on software on production on that. I'm working mostly on open source, so I have interaction with those people. But if you want to speak about that, I think there is a demo on the other side about using hypervisor on automotive. So feel free to talk with them on the demo booth. I think we are running out of time, so if there is one last question on...
I have a question, like not so technical, but with our customers, we usually see such situation when customer selects some platform using maybe like a set of features that it needs to support. And often with ARM, we see such situation when even if we have hardware ready for everything, in software we have some lack of support in current software or by community. So can you say that current Xen is ready for something like cloud computing? So is it ready for production? Is it ready for servers at this time?
So at this stage, I will say that we are still working on with people, but like we know that we have all the components there, but we are still trying to understand what's missing on filling the gap, and we are close to filling the gap on any hypervisor today, even on Xen. There will be some complex things on Automotive, and I think there will be a talk during the day where they address all the challenge on Automotive, but it needs to be addressed. I admit that it's quite complex when you got different set of devices that needs to be shared there. So this needs to be thought with the community and with people wanted to use the platform. Yeah. So I think we are done. Thank you, everyone.